Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about bioethanol. So let's dive right into it. Now, what exactly is the problem that we need something like bioethanol? Well, reality is we need liquid fuel. Flat out, there is no alternate to liquid fuel. There is no battery system that can perfectly replace it. So that's the reality of it. And fossil fuel is not something that we can keep using it because it's literally harming us. It's harmful to us ourselves. So we have to be very mindful with what we do. Now, because of the large population and because of our industrial agriculture, we have huge agricultural waste. Now, that creates a scenario where you have two problems. How do you solve it? Now, from many countries' point of view, including USA, we are dependent on what we call foreign oil, meaning somebody else feeds us oil. So that creates a scenario. Now, again, you can start a war, but war is not cheap. So you always end up losing. So fundamentally speaking, all countries are generally dependent on someone else, unless you are Russia. So in those sort of scenarios, that's a really bad situation from a national safety point of view. And there is no proper one solution fits all right now, meaning you can try hydrogen car, does not work. You can try electric, it does not work. So that's the serious problem. There is nothing that even comes close to liquid hydrocarbon. So what can you do? So ethanol is looked at as a possible alternate. Now, ethanol is basically drinking alcohol, and ethanol looks like a hydrocarbon, but you have to understand there is an oxygen here. So generally, it's classified as alcohol category. Now, you can have C2, you can have C3, C4, you can keep going higher and higher, but generally, these are classified as alcohol group, not hydrocarbon group. Hydrocarbon is like methane, propane, butane, ethane, peptane, heptane, those sort of thing. Now, this is not that. This is alcohol group. So C2H6O. That's this puppy. Now, it's liquid at room temperature. That's the one of the amazing aspect of it, because C2, you know for a fact that C2 is just a gas. Like if you have C2 H6, it would be a gas. It's like one step below methane. Methane, ethane is just basically a gas. So this puppy is liquid in normal room temperature. It does boil off very easily, but still a liquid. So that's one good thing about it. And it has insane amount of use, meaning this is something that we use GG amounts of it, meaning in medical industry, in industrial sector, we consume this puppy like there is no tomorrow. We know how to make this. We know how this works. It's something that we know and we consume tons of it. Now, one critical aspect of it, this puppy burns almost invisible, meaning this is a real life event where F1 was trying to use ethanol system and somebody caught on fire. Nobody could see what was happening, and this incident literally created a safety protocol. When if you are using high octane fuel, if it burns, there is a very good chance you will not be able to see it. So if that happens, if you are using high octane fuel, if you have even probability of there is a fire, you just douse the person. You don't think about it. It's like what is happening. Like everybody was running around because nobody could see the fire. But you have to understand, after this incident, people were like, you know what, alcohol fires are very serious. Thou shall take care of it. So this is one thing that we have to understand. Even accidents also we know. And that's why recently something similar to this happened, but that time people were trained. They were like, okay, there is a probability of fire. You just douse that person. Don't think about it. Just douse that person. So that's the ethanol aspect of it. So how do we make this magical thing? Well, we have been making alcohol for centuries or even thousands of years. So this is one thing that we know. This is like, we got this, fam. We got this. This is one thing that we are good at. Now, the fundamental core principle of making this is fermentation. Basically, main method of utilizing yeast to do the work. So yeast basically metabolizes sugar. Now, sugar is generally C6H12O6. So it takes that puppy, breaks it down. Now, breaking it down gives you ethanol, but does create carbon dioxide. So be mindful, it's not completely clean process. So ethanol and carbon dioxide is the output, and yeast only needs what we classify as favorable condition, meaning the food supply should be there and there should be adequate temperature. That's why thermal condition is very critical. Generally, they expect around 50 degrees Celsius. So depending on yeast variety, you could have different scenarios. Now, there are some advanced processes that are a bit more complex to set up, but they do allow even bigger brother of this puppy to be used, which is cellulose. Now, cellulose is a very interesting thing because this sugar content is not very easy to find in many crops. However, the moment you start to consume cellulose is one of those things that's the primary agriculture waste. Basically everything has this cellulose. That's the structural aspect of things that we don't eat. So if you're digesting a crop and if you have GG amounts of cellulose, if you can directly convert cellulose into this fuel, GG. Now, we know how to do this. It's just that it's very hard to do. It's not like yeast part, that's easy. That take it and go. People do it. We call it moonshine. It's super easy to do. But cellulose, that's like, good luck kind of hard thing. But again, feasible is just like economically not viable yet. People have figured it out. People are trying to make mass production equipment, right? And if we start to use cellulose part of it, then we have like a really big consumption pool. Right now our consumption pool is very limited to high sugar content basically crops, so to say, energy crops as we call them. So that's the process aspect of it. Now you have to understand, on paper it sounds awesome. It's something that works from agriculture. It has carbon cycle, and we know how to do it. But yes, there are some serious limitations to this. Now, alcohol group is flat out not as powerful as hydrocarbon. Let that be very clear. How clear? You're talking about 21 megajoule of energy per liter compared to 34. What does that mean? That simply means if you had a railway locomotive, that's like big GG locomotive, and it has like 5,000 liters of tank capacity. You replace that puppy with basically, instead of diesel, you put ethanol. Don't expect that engine to go very far. Like, it will work very well, but it will not go very far. And not to mention, in some scenarios, if you use methanol, basically higher version of it, it has engine destructing properties. So that's why it's generally limited with basically racing system. So you have to fundamentally, it does not have the energy. The same problem as basically hydrogen. But hydrogen is really bad. Hydrogen, like liquid hydrogen, is like 8 megajoule. So this is not that bad. So that's why it's almost mixable. But it does have one additive advantage, meaning it is classified as what we call octane booster. Now, thankfully, there are people who knows this. I have no idea what the heck that means, but it simply means the combustion is far more efficient. The emission of carbon monoxide is far less because it does have one oxygen in itself. So it does help combustion to be better. So it's like you are throwing away less energy rather than like, you start with 34, but you waste majority of it. Was the point. So it's like that you start with 21, but you get more out of it. Basically, larger percentage of 21 is used compared to a smaller percentage of 34. That's why it does boost efficiency. And if designed is to run on 100% ethanol, you can achieve ludicrously high RPM. If you desire that, for example, dragster, if you desire that, you can achieve that. Now, it does not touch diesel fuel and jet fuel. That's why you will always hear ethanol mixed with basically gasoline or petrol or light fuels, basically. You do not touch heavy boys as like diesel fuel and jet fuel. You do not touch those things. Again, you can blend it, you can make them work, but at that point, it's like, why? So that's the one thing. Now, it does have a certain limitation, because if you directly think about what we call energy crops, we do not have enough farmable land in entirety of the planet to even cover 100% of the petrol use. Let that sink in. 100% of the petrol use is impossible to achieve simply on the all farmland possible. And not to mention, we are not even talking about 100% of fuel use. I'm not talking about heavy fuel that we consume in gigaliters. Basically, like, think about how much fuel aircraft carrier consumes. A lot. How much this puppy consumes? A lot. So we think about bikes, cars and all that. Yeah, they are small puppies. Like a locomotive is like, I'm the guy. So there are some serious limitations on this. It does take years of agriculture, especially if you are utilizing glucose rather than sugars, but those are ludicrously common. I have provided a video down below, which is from like few years ago, and India, somebody built a plant like that. Like, it is something that we have been doing, but it's never something largely successful. However, there are some serious, horrifying dangers to it. Meaning, because of the large scale involved, meaning this is not something, oh, we made 1 liter. It's something that we are making gigaliters of it. It gives a false sense of scale where it can do it. Reality is it can't. It's like a human brain is really bad with big numbers. And it's, again, we are humans. We are emotional, not logical. We are not Vulcans. So there is some serious limitation. And that's why, like, it's very tempting. What if we do it? It's like, no, you can't do it. The moment you expand it to like full scale, then you're like, oh, it does not work. That's the problem. And it inflates the price of crops. That is really bad. Meaning, think of it this way. Now, sugarcane will be used. It will make sugar. Then the waste product will be used into fuel. Now you will like, that isn't that awesome? Isn't that GG? Yes and no. That's GG because you got sugar price, literally sugarcane price will go up while sugar price will remain the same. Now here's the problem. Sugarcane price went up, meaning sugar mill was willing to pay a bit more to acquire larger quantities of this because they knew we can extract sugar, which itself is profitable, and then we have extra profit from waste product. Now what does that mean? That simply means every farmer will be incentivized to like, hey, what if we do not crop like, cotton, wheat, rice, barley, oak, things? What if we don't do things and do energy crops? And that's what's happening in Brazil. Meaning it literally creates an incentive scenario where everybody's like, what if we, rather than growing crops or potatoes, things of that nature, what if we just grow this? Because it has double price. Even though your price of sugar is more or less the same, it has double price on this. So everybody's like, And it because if you have politicians who are not qualified, not educated, especially in large mathematics, they'll be like, let's make a law that makes it 10% mandate. Why? So it's one of those things, and it incentivized deforestation. Now, if you have followed the news in 2020, which I will not blame you if you did not, because the world was ending and still ending. So something bad happened. Brazil literally started deforesting the entirety of basically green forest that they had. Now, why? That is the one thing that you have to understand. It's one thing that looks very good, but because we are utilizing the easy route, which is again easy, we're like, what if we just plant, fuel crops? Not good idea. And we need food. I need this puppy more than I need fuel. So that is the one thing. Now, how about you compare it? Like, is there any possible alternative? Yes, it does not even come close to seaweed. This puppy is good. Seaweed is better because this creates alcohol, this creates hydrocarbon, and this creates almost jet fuel. And be mindful, we have been using seaweed for multiple other secondary products, so we know how to make them, and we know how to manufacture them large scale and all that. We can achieve what we call crude oil. Yes, you heard me right. Meaning, if you're growing seaweed in very large quantities, as in like gigatons of it, you can make crude oil. Meaning that crude oil you will ship, like barrels of it, you will ship to basically fuel companies and like use it. And it will have the same outcome. Basically, it will have jet fuel, it will have diesel, it will have petrol, everything. That is doable. It's basically fossil fuel on steroids in terms of time. It's shrinking the time variable of it. So that's why ethanol, while it sounds good, it does in principle is like, hey, we can like, reduce the wastage and reduce spare methane emission in the atmosphere. The reality is always creates a very bad situation for us, because any country who's like seriously investing, they have to be very mindful of it. They have to be like, there won't be any incentive. There would be just like, a bonus if you are reducing the waste, bonus if you are reducing the CH4 emission. So those sort of things, that's awesome. The moment you're like, we're gonna mandate a law that's like, with that, then it starts to backfire. And USA is now finalizing its 20-year try one. Now they are looking at back at that corn boom that they created. They're like, this was a bad idea, like really, really bad idea. It produces more carbon dioxide. So that's why there are some serious danger involved in it. It looks good, it sounds good, but it's not hydrocarbon. So why not you use hydrocarbon? And we have more than enough surface area in the sea. And it has also secondary benefits of like cleaning the microplastic in the sea. So that's the reality of it. So be very mindful whenever you are talking about like, crops into fuel. Remember, you need fuel here. So this was my presentation on basically bioethanol. What is it? How does it work? Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.